right. Hey, I am the Chief Science Officer at Striveworks, so I lead kind of the machine learning model development side of the house. And one of the things we work on in particular is optimization, and especially for deep neural networks. So I'll talk a little bit about that today. One of the main efforts when you want to, operationalize a neural network is you want to optimize it, because typically these networks, compared to more traditional machine learning techniques, are very big and slow. So they take up a lot of memory, which is expensive because GPU compute is not cheap, and then they can take a long time to process a single data point. And so there's a few techniques you can do and that we do to help bring down that model size and also increase the speed. And so one technique is called neural network quantization. And so the idea here is that inside a neural network, the basic operations, or the majority of the operations, are really just multiplication and addition. And so sometimes you can kind of reduce the precision of these parameters that you're multiplying. So for example, maybe you trained a neural network, you have parameters that have 10 decimal points. Well, you might be able to cut that down to 5 and retain the predictions and the accuracy of that model. And by doing that reduction, as long as you don't sacrifice that performance, you'll get a significant speed up as well as reduced memory footprint. So that technique, quantization, is something we've done before, especially when we're looking to take something we trained on a server and then deploy it to an edge device like NVIDIA Jetson. There, it's really important to quantize because you have very limited resources, and we've had success doing that. Another technique is called model pruning. And so the idea here is, you have this big network, it's very complicated, you have lots of layers to it, and it happens in many cases that some of those layers really aren't having a big effect on the prediction. And so you can just really cut out completely those computations and not do them. So really pruning away some of these kind of subgraphs in the neural network. And so that's something that actually we had a journal club presentation on a bit ago by our data scientist Travis, who also incorporated that technique into our platform Chariot. So there's kind of an art to that technique. You want to make sure you don't prune too much, otherwise you lose performance of the model, which obviously you don't want. And so he developed some methods of kind of doing that in an automated fashion, which is really cool, and it turned out to be really effective. Another technique goes by the name of knowledge distillation. And here the idea is to take a really big network that you can train to high performance, use that as a teacher to then distill its knowledge onto a smaller, faster network. And so, here you just train the big network in the typical way. And then there's a few different types of methods where you can train the student network, the smaller network, based off the output of the teacher network. And the really cool thing about this is that you typically get better performance for that smaller student network by training it using the teacher network than you would if you had just directly trained the student network on its own, which is really interesting and a bit surprising. Those are the three techniques we've used. So, model quantization, model pruning, and knowledge distillation, and incorporated a lot of these into our platform, and it's really helped speed up deployments.